This is the simplest way to create your own MCP server from scratch. In the last video, you learned how MCP works and how to connect MCP clients like Claude Desktop with MCP servers to access databases. The solution was already capable of reading and writing database entries independently. Not exactly good news for all the database admins out there, right? We also gave Claude access to the web and your local file system, which is cool but could also lead to interesting and sometimes alarming results. But why stop there? Imagine building your own MCP server that can communicate with your favorite APIs, project management tools, or time tracking software. Or even better, imagine connecting it to the Pokemon API, which includes detailed data for over 4,000 Pokemon. But why should you even care about building your own MCP server? We already have a large list of MCP servers readily available for you to use effortlessly. All we need to do is add the configuration to Claude Desktop and enjoy the new functionality. But what if the available MCP servers don't fit our specific use case, or we prefer not to rely on external source code? At first glance, the implementation might seem complex and overwhelming. However, the underlying idea is actually straightforward and can be broken down into two simple concepts: resources and tools. Let's illustrate this with a simple example. Imagine we ask Claude to provide the stats for a single Pokemon, Pikachu. Claude responds by asking if it can use our brand new tool, GetStats, which we'll implement shortly. But how does Claude even know that such a tool exists, and how does it understand how to use it? For this, every MCP server must implement 4 key methods: list resources, read resource, list tools, and call tool. We need list resources in MCP servers to provide a structured catalog of available resources, enabling tools to discover and interact with them efficiently. We need read resource to fetch detailed data about a specific item so tools can use it. We need list tools to provide a catalog of all available tools, their functions and input requirements, so they can be easily discovered and utilized. And lastly, we need call tool to execute a specific tool with the provided input, allowing us to perform the desired operation and retrieve the results. Let's build a custom MCP server together in the next 4 minutes. You'll see, it's easier than you might think. Let's start by creating the blueprint for our MCP server. We can do this effortlessly using the create MCP server command. By using the _path parameter, we can specify the name of our project. In this case, we'll call it Pokemon server. To keep things simple, we'll stick with the defaults and won't add a description or any extra details. Once the server is created, the command automatically detects that the Claude app is installed and asks if we want to integrate the new server configuration into Claude's setup. To verify what's been automatically added, we copy the path of the configuration file and open it with our favorite editor. Inside, we can see that our new Pokemon server has been registered. It's simply a UV command with arguments specifying the directory. Next, we navigate into the directory. Inside, we'll find a source directory containing a file named server.py. This is the only file we'll need to modify. To make things interesting and learn the most, let's start completely from scratch. We'll delete all the existing content in server.py. For now, we'll hardcode a list of Pokemon to keep things simple and avoid diving into API call logic. As a starting point, we'll have just one entry, our beloved Pikachu. You probably remember the 4 methods we need to implement. The first one is list resources. As you can see, we simply return a list of so-called resources. Each entry contains a unique URL, a name, a MIME type, and a description. Let's add the necessary imports and try it out directly. We can call this method to see what MCP clients would get. This way, you can really understand what's happening under the hood. Let's start the script and you'll see the structure of the data. If you're wondering, the condition ensures that the code runs only when the script is executed directly. We get a list of Pokemon resources. This is enough for the MCP client to identify which Pokemons exist. For more details about a specific resource, an MCP client would call the next method. Do you remember what it was? Right, it's the read resource method. This method takes the unique URL and returns all the details of the resource. In the case of Pikachu, it doesn't just return the name and description, but also the stats. Now it's time for our next method, the fabulous list tool method. With the list tools method, we tell MCP clients which tools exist. In our case, it's just one tool with the name getStats. We define the name of the method, a short description, and very importantly, the input schema, which specifies the parameters it expects. All right, let's try this method out as well. As you can see, it returns a list of tools. Do you remember what the last method was? Exactly, it's the call tool method. This method is a bit longer because we need logic to determine which tool should be executed. For this, we add a simple condition. If the tool name equals getStats, it returns the stats of the Pokemon, including its name and its detailed stats. Let's try it out. If everything works as expected, we can move on to the final steps, connecting it to the MCP client and trying it out in Claude Desktop. Looks good. It's returning the stats for Pikachu. Now we replace the main method to handle communication streams between the MCP client and our server. We use the standard I/O server to manage the input and output streams and pass them to the app.run function. This ensures the MCP server is ready to handle requests, process input, and send output streams back to the client efficiently. Great. Now we have everything ready to start Claude Desktop. Once Claude Desktop starts, we can already see on the right-hand side that it has detected one tool. When we click on the tool icon, it lists all available MCP tools, and we can see the getStats tool from our Pokemon server. Perfect. Let's test it out. We type, "Please provide the stats for Pikachu." Claude then asks us if it's allowed to access the getStats tool from the Pokemon server. We agree, and immediately we get the result. Pikachu's stats appear, and that's it. We've successfully built and tested our own custom MCP server. As you can see, it's not as hard as it seems. Now it's your turn to give it a try. If you have any questions or run into any issues, feel free to ask in the comments below. I'm happy to help. Good luck!